So quiz tomorrow is 13 questions. Starting with 9.1, it says evaluate the 6 trig functions of the angle theta. So we first have to notice where theta is. It's up top here. So what would 12 be? Opposite, adjacent, or hypotenuse? Opposite. What about 5? Adjacent. How do we find the hypotenuse? Pythagorean theorem. Awesome. So 5 squared plus 12 squared equals h squared. Or you could say c squared. It's our hypotenuse, as long as it's equal to the hypotenuse. So 5 squared would be 25, plus 12 squared is 144. Is equal to our hypotenuse squared. So 169 is equal to our hypotenuse squared. What's the square root of 169? 13. Awesome. You do not get a calculator for the quiz tomorrow. So our hypotenuse is 13. So now we're going to use SOHCAHTOA to find our 6 trig functions. So sine, cosine, tangent, then cosecant, secant, and cotangent. I know remembering which one goes with which is kind of like the challenging part here to remember the other 3 reciprocal functions. One way that I kind of like to think about it is that like each pair, so if this was a pair, this was a pair, this was a pair, each pair, only one of them starts with a C. So cosecant starts with a C, cosine starts with a C, and cotangent starts with a C. So no pair has 2 that start with a C. So it's kind of one way to remember it. Whatever you got to do to remember which one goes with which, you can do it, but this is how I like to think about it. And I think when I did this in high school, I used to think that cosine and secant are like the same thing but backwards. They're not, but almost. So again, that's how I remembered that they go together. So sine is opposite over hypotenuse. So opposite would be 12 over our hypotenuse is 13. Cosine is adjacent over hypotenuse. So adjacent is 5 and our hypotenuse is 13. And then tangent is opposite over adjacent. So that would be 12 over 5. And then with our reciprocal functions, we just flip it. So cosecant would be 13 over 12. Secant is 13 over 5. And cotangent is 5 over 12. All right, let's take a look at the next section. It says, let theta be an acute angle of a right triangle. Evaluate the other 5 trig functions. So here it gives us tangent of theta is equal to 3 over 4. Well, tangent in terms of SOHCAHTOA is what over what? Opposite over adjacent. So 3 would be our opposite and 4 would be our adjacent. So how would we find our hypotenuse? Pythagorean theorem. So 3 squared plus 4 squared is equal to, we can say h squared or c squared. If you want to, you can draw the triangle. If you like to see it a little bit better by drawing the triangle, that would work too. So this would be 9 plus 16 is equal to h squared. So 25 is equal to our hypotenuse squared. We take the square root. So what's our hypotenuse? 5. So let's evaluate our other 6 trig functions. We have sine, cosine, tangent. What goes with sine? Cosecant. What goes with cosine? SEC, secant, and then cotangent goes with tangent. So sine would be opposite over hypotenuse. What's opposite over hypotenuse? 3 over 5. Cosine is adjacent over hypotenuse. 4 over 5. Tangent is opposite over adjacent. 3 over 4. That one was given to us, which now we just need to flip them to find the others. So cosecant would be 5 over 3, secant 5 over 4, and cotangent 4 over 3. One more that I want to do, I think it's a 9.1, that's not on the review, is a special right triangle one. So let's say we were given a right triangle and our angle down at the bottom was 60, and we were given that opposite of 60 is 5, and we're asked to find x and y. So if one of our angles is 60, that means the other one is 30. What's opposite of the 30? So opposite of 30, start with the smallest, that's just our A. What's opposite of 60? A square root 3. And what's opposite of 90? 2A. So A square root 3 is equal to 5. Let's figure out what just A is, and then we can plug it in to find our other answers. How would I solve for A here? Since A is being multiplied by the square root 3, we divide by the square root 3. So A is equal to 5 over square root 3, but we can't leave square root 3 on the bottom. So we have to rationalize. So we're going to multiply the top and the bottom by square root 3. So A is equal to what? Awesome, 5 square root 3 over 3. So we're going to take that, plug it into our A. So we have x is equal to 5 square root 3 over 3. And then plug it into the A in the other equation to find y. So y is equal to 2 times 5 square root 3 over 3. Awesome. 2 gets multiplied on top, so it would be 10 square root 3 over 3. These would be our 2 answers. So it's important to know your special right triangles in a 30, 60, 90 triangle. Opposite of the 30 is your A, opposite of the 60 is A square root 3, and your hypotenuse or opposite of the 90 is 2A. And then in a 45, 45, 90, the 2 legs, or opposite of the 45s, are your A, and the hypotenuse is A square root 2. So these you need to know. Any questions here? There's a lot of examples that we did from the notes for these questions for 30, 60, 90. And I think we had a homework assignment that was just this too. So if you want more practice, go back and look at the homework. All right, next page. All right, let's take a look at number 6 on the next page. It says draw an angle with the given measure in standard position. So for number 6, we don't know where negative 3 pi over 4 is. So what would we need to do to figure out where it would go? Multiply by 180 over pi. We want to convert it. So when we convert, the pi's cancel. 4 goes into 180 how many times? 45. Awesome. The more you practice this, the more you start to deal with the same numbers again and again. First question we did with this, we might not have known that 4 goes into 180 45 times, but we did like 3 of these yesterday. So the easier it gets, the more you practice. Negative 3 times 45, if you don't know that, write it out. 45 times 3, 3 times 5 would be 15. 3 times 4 is 12, plus 1 would be 13. So negative 135. So a negative angle, we start by going down. If it helps, draw your degrees backwards. So this would be 0. We have negative 90. Negative 180, negative 270. So if this was quadrant 1, 2, 3, and 4, where would negative 135 go? Quadrant 3. Awesome. So it'd go about here in quadrant 3. So this would be our angle. All right. 7, 8, and 9 are just matching. So you match with the angle. Let's look at 11. It says find one positive angle and one negative angle that are coterminal with the given angle. So for coterminal, we add or subtract 360. So how would we find a positive coterminal angle? Awesome, we add 360. So that would give us 320. Is 320 positive? Yes. So always just make sure, double check that it's positive. You can add or subtract 360 as many times as you want. Let's find our negative coterminal angle. How would we find a negative coterminal angle? So negative 40 minus 360 would be what? Awesome, negative 400 degrees. Is negative 400 negative? Yes. All right, let's take a look at 15. It says convert the degree measure to radians or the radian measure to degrees. All right, so 15, we're converting to radians or to degrees. So 15 is given to us in degrees, so let's convert to radians. What do we multiply to convert to radians? Pi over 180. So let's simplify. What goes into both 160 and 180? 20? 20 goes into 160 how many times? 8, right? So negative 8. And 20 goes into 180 how many times? 9. Can we simplify any more? What are we left with? Negative 8 pi over 9. Awesome. Let's do the same for 18. We're converting to degrees. So what do we multiply by? 180 over pi. So pi's cancel. What goes into both 8 and 180? Let's try 4. 4 goes into 8 twice. 4 goes into 180. Let's see. 4 with 2 left over. 4 goes into, 4 goes into 20 5 times. So 45. Can we simplify any more? So what do we have left? Negative 45 over 2 degrees. Don't forget when you're converting to degrees, do not forget the degree symbol. If you want to, you can put it as a decimal.
The top one, that's converting into radians?
Radians, yeah. If it gives it to you in degrees, convert it to radians.
We get points off for forgetting
If you're talking about degrees, make sure you put the degree symbol. The third quadrant. Let's take a look at number 4. So we're going to evaluate the 6 trig functions here. So here it gives us a point. So this is x and y. So we need to figure out what r is. How do we find r? Pythagorean theorem. X and y are kind of like our legs, and r is our hypotenuse. So we have negative 2 squared plus negative 6 squared is equal to r squared. So 4 plus 36 is equal to r squared. So 40 is equal to r squared. Take the square root. Here we have to be careful. We can simplify the square root of 40. What are 2 factors of 40? 2 and 20, or you could say 4 and 10. That works too. What are 2 factors of 20? 2 and 10, or 4 and 5. Again, you can break it down however you want. You'll end up with the same factors at the end. 2 factors of 10, 2 and 5. So we circled 2 of a kind here. We've got 2 2s. So what comes to the outside? 2. And what stays on the inside? 2 times 5, which is 10. So our radius, or our r here, is 2 square root 10. So now let's find our 6 trig functions. Sine, cosine, tangent, cosecant, secant, and cotangent. Now here, it doesn't give it to us in opposite, adjacent, hypotenuse. It doesn't give us the triangle. It gives it to us in x, y, and r. So we have to know what sine is in terms of x, y, and r. Sine is what? Y over r, perfect. Cosine is what? X over r. And tangent? Y over x. And then we have our reciprocal functions, which are just going to be the flips of our answers. So with sine, it would be y over r. What's our y? -6 over, what's our r? 2 square root 10. All right, let's simplify this. What can we do first to simplify? We can divide the top and the bottom by 2. That'll make it easier for us. So we get -3 over square root 10. Now what do we have to do? Rationalize. We're going to multiply the top and the bottom by square root 10. So we're left with -3 square root 10 over 10. Questions here? All right, let's do the same thing for cosine. Cosine is x over r, so that would be -2 over 2 square root 10. Let's simplify. 2's cancel. So if you have a whole number 2 on the top and the bottom, they cancel. So we're left with -1 over square root 10. Can we leave our answer like this? No, we have to rationalize. So multiply the top and the bottom by square root 10. What do we get? Negative square root 10 over 10. And then lastly, tangent is y over x. So that would be -6 over -2, which simplifies to 3. Awesome. Yes. Any questions on those 3? All right, let's find our reciprocal functions. So cosecant, I would recommend not flipping the one that's already rationalized, because then you're going to have to rationalize it again. You could either flip the original or flip the simplified one. Either way would work. If you're not comfortable with how you simplified, let's flip the original and then simplify after. So this would be 2 square root 10 over -6. Can we simplify this? What goes into 2 and 6? 2. So it would be square root 10 over -3. Do we have to rationalize this one? No. Square root can be on top. It's not on the bottom. Let's do the same thing for secant. So we're going to flip the original. So it'd be 2 square root 10 over -2. 2 goes into 2 on the top and the bottom. So we're left with square root 10 over -1, which would simplify to what? Awesome, negative square root 10. And then cotangent, we're going to flip the original. So we get -2 over -6, which simplifies to what? Not 3. 1/3. Awesome. 3 would go on the bottom, so 1/3. So these would be our 6 trig functions. So when it gives you the triangle, you can just use SOHCAHTOA. But if it doesn't give you the triangle, you got to use X, Y, and R, which is the same thing, really. But you just need to know sine goes with Y, cosine goes with X, and tangent is Y over X. Yes. All right. The next two questions, or three questions we're going to do, 7, 10, and 13, we want to use just 7. We want to use the unit circle to evaluate. All right, so for number 7, we want to use the unit circle to evaluate the 6 trig functions. So 7 gives us 3 pi over 2. So we want to look for 3 pi over 2 on our unit circle. Where would 3 pi over 2 be? Where's 3 pi over 2? At 270, down here. So we're going to use the point 0, negative 1. No, unit circle will be given to you on the quiz tomorrow. Just got to know what to do with it. So now let's find our 6 trig functions. Sine, cosine, tangent, cosecant, secant, cotangent. So again, we don't have a triangle here. Whenever it says use the unit circle, we use our X, Y, and R. But unit circle, R is just 1, so here we're just using X and Y. So sine is what? Y. Cosine is X, and tangent, Y over X. And then our reciprocals would be the flip of it. So 1 over Y, 1 over X, and X over Y. So what's our Y? Negative 1. So sine would be negative 1. What's cosine? 0. And tangent would be Y over X. So negative 1 over 0, which is undefined. Awesome. You cannot have 0 in your denominator. So that would be undefined. Now let's find our reciprocal functions. We have 1 over negative 1, which simplifies to what? Negative 1. Secant would be 1 over 0, which simplifies to undefined, because can't have 0 in the denominator. And cotangent, when we flip it, would be 0 over negative 1, which is 0. 0 on top is 0. 0 on the bottom is undefined. So these would be our 6 trig functions. All right, in the last 2, we're going to find the angle's reference angle. So remember, with our reference angle, there's 2 things that it always has to be: acute and positive. Remember, it's like the smaller version of the angle that's given. So if the question gives us degrees, the answer has to be in degrees. If the question gives us radians, the answer has to be in radians. So reference angle is like the smaller version of the angle that we're given. So if we have 220 degrees, how would we find the reference angle? Well, first we need to figure out what quadrant it's in, because each quadrant has a different formula. Which quadrant would 220 be in? The third quadrant. The third quadrant's in between 180 and 270. What formula do we use?
180 minus theta.
So if we did 180 minus 220, 180 minus theta, that would be negative 40. Can our reference angle be negative? No. So we can't use that formula. So it's the wrong one. What do you think our formula is? Theta minus 180. So 220 minus 180 would be 40. Can we leave our reference angle in degrees? Yeah, the question gave us degrees, so our answer has to be in degrees. If you're in the first quadrant, whatever your reference angle or whatever your theta is going to be the same as the reference angle. Second quadrant, we do 180 minus theta. Third quadrant, theta minus 180. Fourth quadrant, 360 minus theta. You're welcome. All right, last one. Let's do 13. So we don't know what quadrant negative 7 pi over 3 is. So what do we need to do? Convert it. So let's multiply by 180 over pi. Pi's cancel. 3 goes into 180 how many times? How many? 60. What's 60 times negative 7? Negative 420. Now we can't use our formulas if our angle is more than 360 or if it's negative. So let's find the positive version of this. What do we need to do to find the positive version? Add 360. When we add 360, what do we get? Negative 60. Again, it's negative. So what would we need to do? Add 360 again. So we get 300. So what quadrant are we in now? The fourth quadrant. What formula do we use in the fourth quadrant? 360 minus theta. So we would do 360 minus 300, which would be 60. So 60 degrees is our reference angle. Can we leave our reference angle in degrees here? No, because the question gave us radians. So we need to convert back. So we're going to multiply by pi over 180. How many times does 60 go into 180? 3. So what would our answer be? Pi over 3. So in number 2, it gives us a point, which we'll say x and y, and it asks us for our trig functions. So we need to find sine, cosine, tangent, and their reciprocals. So cosecant, secant, cotangent. So it gives us x and y. We need to figure out what r is because this is not a unit circle. So we need to find r. So we can use Pythagorean theorem to find r. So we use x squared plus y squared is equal to r squared. So x would be negative 4 squared plus 1 squared is equal to r squared. So 16 plus 1 is equal to r squared. 17 is equal to r squared. Take the square root. So r is the square root of 17. Always check to see if you can simplify your radical. What are 2 factors of 17? Do we have any other than 17 and 1? Nope, so can't simplify. So r would be square root 17. So now let's plug everything in. Sine is y over r, cosine is x over r, and tangent is y over x. So sine would be 1 over square root 17. Can we leave square root 17 in our denominator? No, we have to rationalize. So we're going to multiply the top and the bottom by square root 17. So we get square root 17 over 17. Let's do the same thing for cosine. So cosine would be x over r, so that's negative 4 over square root 17. Can't leave the square root in the denominator, so we have to rationalize here. So we multiply by square root 17 over square root 17. So we get negative 4 square root 17 over 17. And then for tangent, we have y over x, so that would be 1 over negative 4. Now let's find our reciprocal function. So we're going to flip before we rationalize, because there's no point of rationalizing, then flipping it, ending up with the square root on the denominator again, and then having to rationalize again. So we're going to flip the original one. So we get square root 17 over 1, which would just be square root 17. For secant, again, we're going to flip the original one. So it would be square root 17 over negative 4. And then cotangent, we're going to flip tangent. So we get negative 4 over 1, which is negative 4. Awesome. So these would be our 6 trig functions. Yes. So for questions like this, where it gives you a point, you have to use x, y, and r. So make sure you know that sine is y over r. Cosine is x over r. Tangent, y over x. All right, let's do 5. Actually, let's do 6. 6 says use the unit circle to evaluate the 6 trig functions. So I just copied and pasted a unit circle from the homework. If you want to use that for 5, 6, and 7, we're going to give you the unit circle on the quiz tomorrow. So this will be given. So it says use the unit circle to evaluate the 6 trig functions. Is 450 degrees on our unit circle? How do we find the smaller version of it that's going to be on our unit circle? Awesome. Subtract 360. So 450 minus 360 would be 90. So we're going to use 90. So going to our unit circle, we're going to look for 90 degrees, which would be here. What's our point at 90 degrees? 0, 1. So we're just using the point. That's the whole reason for our unit circle. It's going to give you either a degree or a radian. You're going to look for it on the unit circle and then just use that point. So we're using 0, 1. So once we get our point, you don't need to look at the unit circle again. So the unit circle looks super complicated, but all you're doing is like searching for what your degree is and using that point. So our point is x and y. For our 6 trig functions, we don't use r when we're using the unit circle. So we just have sine, cosine, tangent, cosecant, secant, and cotangent. So on our unit circle, r is just 1, so we don't use the r. So sine is y, cosine is x, and tangent is y over x. And then our reciprocal functions, cosecant would be 1 over y, secant is 1 over x, and cotangent is x over y. I wrote the point down wrong. It should be 0, 1, not 1, 0. So let's try that again. 0, 1. Okay. So sine would be 1, cosine 0. Tangent is 1 over 0, which simplifies to undefined. Cosecant is 1 over 1, which simplifies to 1. Secant would be 1 over 0, which is undefined. And cotangent would be 0 over 1, which is 0. Awesome.
Are we going to have to memorize the y, x?
You have to memorize that sine is y, cosine is x, and tangent is y over x. Gotta know these. All right, we're going to do 2 more, which is find the angle's reference angle. So we did reference angles yesterday. Our reference angles are acute and positive. So don't forget, your reference angles are acute and positive. Let's do 9 and 12. So looking at 9, let's figure out which quadrant we fall in because that determines what formula we use. So would 130 degrees be in quadrant 1, 2, 3, or 4? Quadrant 2. In quadrant 2, we use the formula 180 minus theta. So we have 180 minus 130. What's 180 minus 130? 50. So our reference angle would be 50. Remember, your reference angle is like a smaller angle than the one that's given. It's like the smaller version of it. So if your question gives you degrees, your answer has to be in degrees.
If it's in radians, it has to be.
So let's do 12 now. 12, we don't know what quadrant 15 pi over 4 is in. So we need to convert it to find out. So multiply by 180 over pi. Pi's cancel. 4 goes into 180 how many times? 45. What's 45 times 15? 675. 675 is more than one time around the circle. So how do we find out how much more we're going? Subtract 360. So we get 315. Yeah. So what quadrant would 315 be in? The fourth quadrant. In the fourth quadrant, the formula we use is 360 minus theta. I'll write all the formulas for each quadrant after we do this one. So 360 minus 315 would be 45. Can I leave 45 as my reference angle? No. It is acute and positive, so we know that we did it right, but we need to convert it back. If the question gives us radians, your answer has to be in radians. So what would we multiply by to convert it back? Pi over 180. Well, 45 goes into 180 how many times? 4. So our answer would be pi over 4. And then just for you guys to have, I'll write down all the formulas for the reference angle. So if you're in the first quadrant, whatever your theta is, that's going to be the same as your reference angle. Just make sure it's acute and positive. In the second quadrant, we do 180 minus theta. Third quadrant, theta minus 180. And fourth quadrant, 360 minus theta. If you accidentally use the wrong formula, your answer is either not going to be acute and not going to be positive. So you know you did the wrong formula.
So wait, what's the first one?
Whatever your reference angle is in the first quadrant, or whatever your angle is, it's the same as the reference angle. Because if you're in the first quadrant, it's already less than 90.